So we just finished this hood edge video, and I'd like to talk about a small area. And really, when I really want to get in and optimize some things, this would be just a little more in-depth at the level of investigation I might go to, or the level of modeling that I might work on. So we've developed that clearance zone for this, in a few surfaces. But if we turn off the hood shading for just a second, and we look at, this is just a what I would call a default flange or fillet flange built for this area. Now here's the tangent point where our main shape in the front view stops, and then this accelerated area starts. Okay, so that's important because I would like our transition zone for where this fillet flange begins, or really where my clearance surface, which is what I'm generating all of this data for, is to come up with a clearance surface. I want the optimal one of those. Okay, so I'd like this transition to stop and start at this tangent point. All right, so here we have a solution based on the tangent point. You can see we don't quite hit it at default. If we move to an option where we hit extend on this end that we need, now what we're going to get is a little bit different result. So a different number of surfaces. All right, you can see the number here. So we have approximately 8 versus 12, but still neither one hits the tangent point. Then if I build those individually, so in this case by individually I mean I pick one segment and build it. It lays out this set of surfaces, and then I pick this segment, build it, it lays out those. That gets me kind of an optimal solution. One across this main segment, and then the software is divvying this up in the corner or dividing this in the corner, but I'm stopping and starting right at the tangent point. Okay. Now what I'd like you to look at the difference here is that extend comes up with this spacing for surfaces. Again, not meeting this point that I would like to hold. And individually, when I build it, it creates this type of segmentation. So I see this as kind of a large segment, a smaller segment, and then a larger segment. Okay. When I look at the extend, I see these as kind of more evenly split. Larger, a little smaller, a little smaller. Again, one of my main points though is I want to start at this location right here. All right. So what I'm going to do is kind of optimize this, and I'm going to say, hey, here's an optimal solution. Okay. So if I turn on individual, there's my pivot point, there's my tangent point, I'm sorry. But right here, I get a nice even distribution of these control vertices. Okay, and I've just done a little extend and detach over here. And the point I want to illustrate is if I start with this set of geometry, what I would really like is, since the original, the main theoretical right here is one piece or one curve, I would like this to be one piece. That eliminates a lot of extra continuity checks to perform. And I'd like to talk a little bit now about segmentation. We've been discussing equally spaced or narrowing, not medium, small, large spacing, large, medium, small. Kind of like the optimal is here. Larger, medium, small, where there's more acceleration. So if I bring back the, I'll turn off my shading now. If I bring my individual surface set back and we just look at, a curve that would be created through here. So if I generated a 5-degree curve, and then I duplicate that curve, right? I get these 3 curves, and then I'm going to attach those, okay? And then I could fit those with the fit curve tool. And the control vertice structure I would get for that looks like this. So immediately, with, I guess, my experience, or what I would suggest noting, is the low spot of this control vertice and the high spot of this control vertice. While they're kind of evenly spaced, they're outplaced or pushed further out or tucked further in. They don't look natural. And that's a fit curve, right, from this curve, okay, where these are spaced large, small, medium. If we look at the same scenario with our optimal curve, or our optimal set of surfaces, and from that our optimal curve, and we look at the curve right here, which is simply a curve on surface, right, that's placed right where our draft angle analysis is set up. Okay, so here's our draft angle analysis. This was just our draft angle analysis duplicated, combined, using this tool, attach, connect, okay? And then all I do is I curve fit that main curve, and I try to get a curve made within the tolerance that I'm working to, which I'm working to 0.001, so we're within 0.0009. Okay, so I could make one curve within those 3 curve-on surfaces and have it still be positional within 0.0009. Okay, and if you look at this spacing, see how there's a larger, smaller, evenly spaced, and within 0.009. If we go back and let's do some comparisons with our 2 curves then. So this curve right here, let's turn on our deviation for that guy. That's within 0.009. So if this one is within 0.009 and this one deviation is within 0.009, okay, we've got almost identical curves fit to 2 different pieces. Okay, these would be considered our scan. All right. Let's look at the curvature combs on these 2 curves. Almost identical. Tiny bit of difference here. But what I want you to notice is the difference between the CV spacing on here versus here. Okay, always choose the most optimal. All right, always choose the best. Now I'd like to point out something here. Here is the optimal curve with just its edit points on. So when you're going to try to fit something like this, many users go in and you use the fit curve, all right? And we're within 0.029. Seems pretty good. Let's look at it in the front view. See my distorted control vertices? There's nothing stopping us from coming in here and grabbing some control vertices and beginning to slide those control vertices to where we see is an area of increased curvature, okay? So by deselecting and moving these around, I can affect what the fit is on this curve. Because right now, okay, I'm just adjusting where I think these control vertices should be. After I get it to a spot, or actually iteratively while I'm trying to get it there, it's trying to decide where a control vertice structure in that orientation should be. So you see here how now, just by fiddling around with these a little bit, we're within the 0.001 region. And I'm just bumping these around a little bit, trying to get them positioned where I think a good CV fit looks. Okay. Another thing that helps with this, if you find it's a very complex fit and the calculation takes a long time, go ahead and turn off your history. So I'm going to suspend my history building, and I'm just going to look at these control vertices. You know, you could come in here and turn on a curvature comb, maybe bump up your scale, okay, increase your samples. Everything looks pretty good to me. See a little hook at the end here. By hook, I mean a little acceleration at the end. Maybe I come over here And I'm just going to grab and slide around. I'm going to slide this guy a little bit this way, this guy a little bit over here, his friend, his partner, move you over just a touch, you over a touch, you over a touch, and rebuild history and get my new fit. And we're at 007. Okay, so by just barely bumping these control vertices around, we can get a better fit. Okay, so that's a in-depth, I guess, perspective on what I would do next. And then right after that, I guess, I would delete this. Okay, delete my construction history. I'm sorry, delete my locators. I could turn on my optimal surfaces. Doesn't really matter, because in this latest version, we can make a surface draft from a curve, right? Well, we can make it from a curve or a surface. Surface angle isn't relevant here. So if I made it from this direction and I did it at 5 degrees, okay, and I don't care about radial at this point, we'll just do X like that. If I delete this and I do a surface project normal onto all these guys, that, and then I evaluate for tangency, okay, I make it, I'm 001 off. So we could come in here and just make a couple of tweaks and get that home. Now, what I'd like to test just real quick, because I did spend a few more seconds, I guess, fitting this. And what I wonder is, if I turn on the optimal, I'm going to get rid of those curves on surface. I'm going to check my latest, I'm going to check my curve here, okay, surface, multi-surface draft. From here, let's go 5 degrees, get rid of those curves, surface, project, normal, onto your friends, and evaluate and check that tangency. We've got good, good, and good. So what I've done there is I have fit these 3 surfaces and a curve on surface that crosses those in a different U and V area, but I've made one surface, okay, that can approximate that shape and achieve tangency. That's going to make my next offsets of that surface simpler. Okay, so maybe more than you wanted to know about how I make things Bezier versus many segments.